Hello everyone. In this lecture, I will discuss about the special cases in linear programming. First, we will be discuss about the alternative optimal solution. A given linear programming problem may have the more than one solution which having the same optimal objective function value. Each of such optimal solution we are calling as a alternative optimal solution. This alternative optimal solution will be found in the two conditions. First condition is when the objective function is parallel to a constraint. Second condition is the constraint should form a boundary on the feasible region in the direction of optimal movement of the objective function. So this is we will be discussed with one example problem. So this is the example problem. So maximize z equal to 10x1 plus 6x2 and given the two constraints. So this is the solution for the given problem and this is the feasible region. So this is the feasible region. And next we have to draw the objective function line. So objective function line, how we are drawing in. So decision variable, first decision variable divided by second decision variable equal to the coefficient of the second decision variable divided by coefficient of the first decision variable. So slope is given that one 6 by 10. So it's nothing but coordinates of the 6, 10. So we have to mark the 6 on x1 axis, 10 at the x2 axis. Then we have to join these 2 points. We will get the line for the objective function. So this is the objective function line. So 6 by 10 having the slope. This is will be right as the 3 by 5 also. So this is also one more objective function line. Here observe that one. So objective function line is parallel to the another constraint. So in such a condition we will be form a alternative solution. And second condition we have to observe that one. A constraint should form a boundary on the feasible region in the direction of optimal movement of the objective function. So in this direction, so forming the feasible region of this constraint. Next we will discuss about the second special condition, that is the unbounded solution. Sometimes linear programming problem will not have a finite solution. So it is nothing but it will have in form an infinite feasible region. So let's see here with one example problem. So this is the solution of the given problem. Here I have to observe that one. So this is the lower boundary of the feasible region, but we don't have the upper boundary of the feasible region. So these all having the upper boundary, but we don't have, so this is having the infinite region. In this condition we are calling as the unbounded solution. So next third one is infeasible solution. Infeasible solution means, so when we don't have the unique solution, unique feasible region, in this condition we are calling as the infeasible solution. See here, this is an example problem and this is the solution for the given problem. Here I have to observe that one. So we don't have the feasible region. So there is no common area. So in this condition we are calling as the infeasible solution. So next one is the another special case is the redundancy. So here redundancy constraint is one that does not affect the feasible region. It's nothing but, let's see, this will be, we will be explained with one example problem. See in this example, so this is the feasible region. We have to observe that one, all the three constraints are contributed for the feasible region. Let's see the second example. In this example, I have to observe that one, this is the feasible region. So in the feasible region only second constraint and the third constraint only contributed for the formation of the feasible region. So there is not contributed for the first constraint. So first constraint we are calling as the redundancy constraint. So these are the special cases in the linear programming. So thank you.